We have the design of a non-destructive feed brake for screw delivery for Senior Design 1 in the fall of 2021. It's presented by Taylor Chandler, Grant Dale, Mallory Hall, and Hong Lau. Our supporter is the Weber Group, Mr. Ben Fisher, Ethan Martin, and Mike Rabasco. Our mentor is Professor John Nettles. Our project overview is to design and build a new brake system to replace the current friction stop used by the company. This would eliminate concerns of the fasteners entering the spindle at high velocity. The concerns were that the original design was overly complex, there was more poor material selection, there was a high failure rate due to the number of parts, mechanical components, and the high speed of the fastener. Specifications and requirements. The part must be non-magnetic and able to withstand thousands of cycles. It needs to use the current cap and collar system that the company uses. It must be modular so that it can assimilate different material parts and sizes. It must be able to slow or stop the part with a tube length of 10 meters, and the velocity must be equal to being gravity dropped 1 meter above the speed head. The team is using a pneumatic design, so the part will be air blown through plastic tubing. The flow will continue from a step feeder, and the braking system will be engaged with a solenoid valve that will be operated remotely and autonomously by a computer. There will also be a pressure control valve or regulator to monitor and control the pressure of the system, and an exhaust or relief valve for excess air to be released. There's also an additional option for a perforated tube to be used. Sensors will detect the parts before they enter the brake. There is a bracket to hold the sensor and tube in place at a set distance. This will eliminate distance variation for velocity. This will incorporate a closed-loop control system, and there will be 2 sensors between the brake and the driver system. So this can decrease setup time and make it more adaptive to different fasteners. On the left shows the drawn prototype. On the right is the flow diagram for the system. It will come from the air supply, pass through the pressure regulator and gauge. The control circuit will control the solenoid valve. There will be a manual shutoff in case of system failure before it passes to the air brake. For our planned implementation and budget, we have the initial prototype completed so it can run through standard cycle testing. This will determine the sensor distance and the part velocity upon entering the brake, so adjustments can be made there. We will complete all ordering of materials for manufacturing and test the part at different air speeds and using different fasteners passed through. Also complete the prototype manufacturing.